All right, ladies and gentlemen, in this video we are continuing our discussion on 6.1. In this case, we are going to be talking now about angle bisectors. So we're staying with the same goal, but in this video specifically, our success criteria is going to focus on defining and utilizing the angle bisector theorem and its converse to find some missing variables and specifically some different angle and side measures. So what is the angle bisector theorem? Well, let's recap real quick what an angle bisector is. Remember, an angle bisector is just a ray that divides an angle into two congruent adjacent next to angles. So our angle bisector theorem tells us that, hey, if in fact AD is an angle bisector of angle BAC, then any point on AD is equidistant to the sides of the angle. So BD and BC in this case would be congruent to one another. Okay, if that's the case, how do I know that this is the distance and it's not just a line? Like, for instance, why would this extra line here not be the same length as BD and DC? Well, remember what we said, the distance from a point to a line is not just a straight line. It is the perpendicular line to the other side, the perpendicular line. So those would not be the same. So look for that perpendicular right angle box. And the converse holds true as well. The converse says, hey, if it already shows that the distance from a point to a line is equidistant on both sides of this quote-unquote angle bisector, because we don't know it yet, then we actually confirm that it is an angle bisector. And so now we can make the statement that if these two are congruent, that means that these two angles end up being congruent as well. All right, let's look at some application. It says find the measure of each of the following angles or sides. Measure of G, F, J. Well, what do we know? The distance from J to G and J to H is both 7. If that's the case, that means that's equidistant to one another. The only way this works is if FJ was in fact the angle bisector, making GFJ and HFJ congruent, meaning that this is a value of 42 degrees. In this case, you see down here that QS is definitely an angle bisector because it makes the two congruent adjacent angles. Therefore, SR and SP are congruent by our angle bisector theorem. So we set up an equation. 5x equals 6x minus 5. Want to go ahead and subtract that 6x over, so we get negative x equals negative 5. We divide by negative 1, and x equals a positive 5. It wants to know what RS is, so we throw it back in and substitute into our equation. So 6 times 5 minus 5 looks a lot like 25 for the value of RS. Let's do one more where it's a little bit more application-based problems. It says a soccer goalie's position relative to the ball and the goalpost forms congruent angles as shown. Will the goalie have to move farther to block a shot toward the right goalpost or toward the left goalpost? So what we're saying here is this guy's about to take a soccer shot. These two angles, this little angle right in here and this little angle right in here, are congruent to one another. All right, so those two angles that I just highlighted are congruent to one another. Is it going to be quicker to try to save a shot to the right or to the left? Or I guess really the question is, does it matter which way that he goes? So again, I challenge you, pause the video and see which way that it would go. Well, since that the goalie right now, the goalie is equidistant, all right, to either of the sides of the triangle. So really, it doesn't really matter. So we can kind of say, conclusion statement is that the goalie must move the same distance to block either shot, whether they went to the left or the right.